Alright, have you ever come across a question like this? Now, this is actually double integration, right? This is double integration where we integrate twice with respect to two different variables, right? The first variable here is going to be y. We're going to be integrating with respect to y, then we integrate with respect to x, right? So if you come in contact with a question like this, what do you do? Now, this is what you do. You're going to take into consideration first the inner integration, right? So let's start by integrating x plus y with respect to y, right? With upper limit of x and lower limit of 0, right? Now, since I'm integrating with respect to y, any other alphabet or letter is going to be a constant. Y will be the only variable there, right? So if I'm integrating this constant x, there is currently no y attached to it, so the power of y there is currently 0, right? So if I add 1 to that 0, it becomes 1. The power of y there becomes 1, right? Then you divide with 1, which is going to still leave us with xy. Plus, you integrate y now with respect to y. The power of y there is currently 1. You add 1 to it, it becomes 2, right? You divide with 2. So this is our integral for x plus y with respect to y. So let's take the upper limit of x as 0, right? When we're taking the upper limit of x, that's when y is, having a value of x. Y, y is the variable here that we integrated. So you're going to substitute x for y, right? So this will be x, then this y, you substitute x, right? Plus this is y, you also substitute x square over 2 minus this is x, this is y, right? You substitute 0 plus substitute 0 square over 2, right? This is how you take upper and lower limit. You substitute the upper limit first, then you subtract the same function, but this time around you substitute the lower limit, right? Now I believe these zeros will cancel this out, so let's focus on this. X and x is going to be x squared, as x into x squared plus x squared over 2, right? Now this is 1x squared, this is half x squared. If you put them up, if you sum them up together, you're going to get 3x squared over 2. That's 3 over 2 x squared, right? Now this is what we get for the inner integration there. So let's look at the outer integration, right? Let's integrate what we got from the inner integral, this first integral here, with the second one. So I'm going to be integrating this value now I've got, which is 3x squared over 2 from 1 to 0. My upper limit is 1, lower limit 0, right? 1 and 0, and we'll be integrating with respect to x this time around, dx, right? We've worked with dy, now we're working with the x, right? So let's see what's going to happen here. Now I'm integrating with respect to x, so the power of x here is currently 2. I'm going to add 1 to that power, it becomes 3, right? Then I divide with 3. Alright, so this 3 now we got from dividing with the new power of x. We cancel out the 3 that was initially the coefficient of x, right? So we're going to be left with the upper limit of 1 and 0, then x raised to power 3 over 2, right? So taking the upper limit, we're going to have 1 raised to power 3 over 2 minus the lower limit now happens to be 0 raised to power 3 over 2, right? This will be our answer. That's after 0 cancel out, because 0, that's 0 divided by 2, that's 0, right? So we're left with 1 raised to power 3, which is 1 over 2. So this is going to be the answer, right? Now what we just did is called double integration, right? This is double integration. All right, take care. Do well to subscribe to learn maths, and I'll see you in the next video.